Hi, I'm Jason Yellick, and today I'm going to be speaking a little bit about the upcoming upgrade to the Boba Network, which is Boba Anchorage. This is going to be a fairly non-technical talk, but we're going to be talking about technical things and talking about how we'll be transitioning from our older optimistic roll-up architecture to the newer Anchorage architecture. So, before we get going, let's talk about a few preliminaries. The why of L2s is something that's pretty well understood in the ecosystem. Why do people go to layer 2s? Well, the primary reason is cost. If we look at Ethereum mainnet, transacting on Ethereum mainnet can get very expensive. In fact, lately, fees have been spiking, and even relatively simple transactions can end up costing you hundreds of dollars if you end up doing them at the wrong time. And the more complicated the transaction, the higher those costs are going to be. So layer 2s tend to offer lower transaction costs. What else? Well, higher throughput. There's only a finite capacity in Ethereum mainnet, layer 1. And layer 2s can offer more room for transactions. So certain applications that wouldn't be feasible on a layer 1 are feasible on a layer 2. But really, if we look at those first 2 points, it's really not an answer to why layer 2s. It's a good answer to why not Ethereum mainnet. But why layer 2s? Well, the primary answer here is safety and consistency. Because layer 2s get to inherit many of the security guarantees from layer 1, and I think sometimes that's overstated. There's still things like fraud proofs that we need to do in a layer 2. But because if a layer 1 reorganizes or forks, it causes the layer 2 to reorganize as well, and so you always end up with a consistent state. So if you have 2 layer 1s and one reorganizes, the other generally doesn't. So if you're doing things like bridging tokens or other assets, you can end up with double spend scenarios where it disappears on one side and never reappears on the other, or it never disappears on one side but does reappear on the other. So layer 2s give us a much sort of safer and consistent way to solve these scaling issues of cost and throughput that come from our layer 1s. What is layer 2? So this is a harder, more technical question that people are less likely to know the answer to. And here I'm going to talk about optimistic rollups, like Boba. We start out with a sequencer, and a sequencer is going to take the transactions from the network. It's going to execute them, and it's going to decide on the latest block. Now, because this can just be a single entity, like a single instance in a cloud environment, it's much less expensive than a layer 1, because you've got one machine doing this work instead of a whole network of them. The sequencer takes the block, the transactions, the work it's done, and it records that state onto the layer 1. Assuming that everything goes well, validators get this state, and they sort of re-execute it. They confirm that the sequencer has done its job, that it hasn't maliciously done anything, changed execution results. It basically confirms that things proceeded as they should. And if they did, we're pretty much done. Nothing else needs to happen. And that's really the optimistic part of the optimistic rollup. Let's rewind to 2021. Back when layer 2s are first being developed. So Ethereum is still a proof of work network, and this is the first time layer 2s are really a thing. So if it were 2021, how would you implement a layer 2? Well, we know we need a sequencer that's going to execute transactions and assemble blocks, and it's going to need to record those onto the layer 1, and we're going to need a validator who sort of gets those blocks and info from the layer 1 and confirms everything is executed correctly. Well, What's the state of the art? What's going on? Well, Ethereum mainnet, as I mentioned, is still on proof of work. The assorted Ethereum clients, they all implement this proof of work consensus. But we have some other networks that are not strictly proof of work. We have the Ethereum testnets, like Yellick, that are based on the click consensus. So, how did they do click? Well, they basically took the proof of work consensus, they copied it, they modified it a little bit so that not just everyone could submit new blocks, so that things had to be properly signed. And they kind of added this as a new code path into the Ethereum clients, of the time. So Go Ethereum has its click implementation, and every Ethereum client implements this new click consensus. Now there were other testnet types of consensus that were implemented in other clients, but essentially it was a fork of the existing Ethereum client and its consensus. What else was there that wasn't testnets? You had networks like Polygon that kind of had this weird, bespoke, custom consensus going on. How did they implement that? Well, just like Click, they took an Ethereum client, they copied the proof of work consensus, and then they tweaked it. They changed things a little bit, and now you've got an Ethereum client fork that has consensus for Polygon. So if you're building a layer 2, what's the obvious answer? Well, you take an Ethereum client, you fork it, you tweak the consensus a little bit, and then you add in the bits that to allow a sequencer to work, or to act as validator, and there you go. You've got a layer 2 client. And if we look at Boba today, we've got a Geth client that's a fork that implements the layer 2 bits. So meanwhile, back in 2021, there's also a concern for Ethereum 2.0. That's what the Ethereum main developers are working on. And what's the goal? Well, the primary goal is to eliminate proof of work. Proof of work was supposed to be eliminated, transitioned to proof of stake, very shortly after the original Ethereum mainnet release. But that kept getting, pushed back and pushed back. And in the meantime, Ethereum sort of became a victim of its own success. So as Ethereum became more and more successful, more and more value came to Ethereum, more and more applications relied on Ethereum. And, as a consequence, the transition to proof of stake couldn't be done in, a sort of way that required downtime. We couldn't have, a series of hard forks. We couldn't be reverting state. These things that sort of happened early in the lifetime of Ethereum before it became so successful, that's not going to fly in 2021. This update has to take place such that users don't really even notice. It has to happen all within a block. There can't be any downtime. So how is Ethereum going to go about implementing that? Well, the way they approached it was actually not to do it in the main Ethereum clients. Instead, the implementation was to create an entirely separate beacon chain that had entirely separate clients. And these clients could be developed on the side. These chains could run and operate with no impact whatsoever on the Ethereum 1 ecosystem. And, the work could be done to make this really bulletproof and ready before it ever got involved with any of the main Ethereum, execution stuff. So the beacon chain, it has no smart contracts. It has only really very simple transactions. And it's all about, ordering these blocks from Ethereum 1.0. So over time, the beacon chain begins to follow the Ethereum 1 mainnet chain. And eventually, one day, they flip the switch, and now the Ethereum 1 chain starts following the Ethereum 2 chain. And we just call that Ethereum today. Well, how did they get that switch to work? And that's primarily with this Ethereum 2 engine API. So because the consensus is all done in an external process, and there are lots of different external consensus clients for the beacon chain, there needed to be a way for these external clients to interact with the Ethereum 1 clients, and that is the engine API. So the beacon chain consents, it chooses this is the next Ethereum 1 block. And it's going to tell the Ethereum 1 execution client, this is the latest block, and then the execution client fetches it, executes it, all that. Meanwhile, when the beacon chain needs another Ethereum 1 block to append, because remember, the beacon chain doesn't execute anything. That's kind of the whole design point. The beacon chain asks the Ethereum 1 client for what's the next block. And then meanwhile, all of the validators in the Ethereum 2 beacon chain, they're executing these Ethereum 1 blocks to make sure that the block that was presented is valid, follows all the rules, all of that stuff. So if you were paying close attention, you might notice that the what is an L2 question and this engine API, there's quite a bit of symmetry. So for a layer 2, we've got a sequencer that's deciding on the latest block. And in Ethereum 2, in the engine API, the beacon chain is kind of deciding what the latest block is. Similarly, in the layer 2, the sequencer is recording state. It's recording everything that's needed to reconstruct the layer 2 blockchain onto the layer 1. And for the beacon chain, it's recording all of these layer 1 blocks onto the, or at least representations onto the beacon chain. Now, the part that's probably the most symmetric is that in both cases, the validators are being told, hey, this is the correct block state to move to, and everyone's re-executing and ensuring that that's a valid state to transition to. Let's look at Optimism Bedrock. So Optimism Bedrock, which is sort of the code base from which Boba Anchorage is derived, is really all about being built around this Ethereum 2 engine API. Now, why would you do this? Well, the engine API is already implemented in lots of Ethereum clients, and it was, implemented with the intent and the ability to be extended. Now, that's not to say that there's no changes or additional work to be done in the Ethereum clients. There is still this special deposit transaction that has to be supported. There's special gas mechanics, because on a layer 2, you have to also pay for the gas to post the transaction to layer 1. There's the way reorganization works is a little different. In Ethereum 2, you can't reorg back to a canonical block. But in a layer 2, you can. So there's some little differences. But fundamentally, the diff between an Ethereum client that supports this, Bedrock compatible behavior, compared with the diff of an Ethereum client that supports the legacy optimism, legacy Boba behavior, the diff is much, much smaller in the Bedrock case. There's much less intrusive work that's done, and that's a win from a development perspective, from a security perspective, and most of the implementation actually ends up going into other processes like OpNode, which is sort of, you can think of it sort of like the beacon client that's controlling the ETH1 client. So that brings us to Boba Anchorage. Now, what is Boba Anchorage? Well, that's the uplift of our existing Boba, which was based on the original Optimism, to Bedrock. So this brings with it a more modern, compatible EVM. It brings security guarantees or security upgrades that come along with a newer EVM and client. As part of this, we're adding support for using Aragon as the Ethereum execution client. Aragon is an additional execution client to Geth, and that's going to be a benefit not only for Boba, but for the whole ecosystem. And finally, as we migrate to Boba Anchorage, it's going to allow us to sort of re-examine some of the decisions that we've made in the past, and to look at, if we're implementing our differentiators in the way that we'd like to. So, options for upgrading our differentiators. Well, we've got the Boba Fee token. So the Boba Fee token allows for users to pay for gas in the Boba token as well as in traditional Ether. And in our existing implementation, this was done as a field in the transaction and as an EVM fork. And in Boba Anchorage, we could take the same approach. We could add this as an EVM fork, but we could also implement it in other ways. We could go to account abstraction. Account abstraction is a new mechanism that's become, gaining support in the Ethereum ecosystem that allows for third-party paymasters to build transactions on behalf of users and can, handle doing things like converting tokens into native gas. Or there are other things we could do. This new architecture allows us to do things like sort of benign front running of transactions. So we could inject a transaction that converts user Boba into native ETH using an on-chain DEX or something like that. The second big differentiator we have on Boba is hybrid compute. Now, the original hybrid compute was implemented much like the Fee token, which was as an EVM fork. And we could bring that once again to Boba Anchorage. But we need to ask, is forking the EVM in this sort of way what we want to do? Or do we want to look at implementing a more engine API-like approach, where maybe the hybrid compute ends up being done more in an external process and passed in via the engine API? Or again, we have options like the benign front running, or we could implement it again via account abstraction. There are a lot of possibilities here, and we'll be looking carefully at the ecosystem and our users and how people like using these features as we decide the implementation details for these differentiators. What are the benefits of adding support for Aragon as an execution client? So adding support for Aragon as an execution client, has multiple benefits. Now, the biggest benefit is probably an ecosystem benefit. One of the things about Ethereum that have made it so resilient is the fact that there are multiple execution clients, multiple implementations of the same execution. And so when there's a bug in one execution client, when there's a bug in Geth, or when there's a bug in Nethermind, or when there's a bug in Besu, that doesn't actually take the whole network down because you still have many other execution clients that are working correctly. So by bringing support to Aragon as an execution client that's compatible with Bedrock, we'll be helping everyone, including ourselves, so that our network is more resilient. Now, additionally, Aragon is a client that's got a lot of really cool features. It's designed to sync really quickly, much faster than many other clients do. It has this staged approach where it separates the execution into multiple stages and steps that ultimately allow for optimization of these paths. Really, Aragon, it's a pretty cool client on top of the ecosystem compatibility. So yeah, I think bringing Bedrock support, Anchorage support to Aragon, it's going to be a great thing for our users and for the community at large. Question 2. Do you see a pathway into lowering gas fees on Boba? So, gas fees on Boba. The primary source of gas fees is really the fact that we have to record state and transactions onto the layer 1. That's the primary source of the costs associated with rollups. Now, there are a lot of things in the pipeline that could help with this. There's the EIP on proto-dank sharding. Essentially today, the way that we populate data from into the layer 1 is via transaction call data. And that's the cheapest way that we can inject data into an Ethereum layer 1, but it's really kind of overkill, right? Transaction call data is something that has to be stored by clients forever, right? It's part of the transaction, and clients expect that if you ask for a transaction, you can retrieve the transaction. So proto-dank sharding is going to allow for layer 2s to post data that's only transiently available. So this data doesn't have to be stored forever. It only has to be stored for a couple weeks. And because of this, the costs can be orders of magnitude less. So this is really going to help with all layer 2s, not just Boba, once that gets implemented. There are lots of other technologies on the horizon. There's, lots of cool stuff being done with zero-knowledge proofs. We don't know that zero-knowledge proofs are really ready for, to replace the entire, optimistic rollup mechanism, but there are, eventually, maybe we'll be storing commitments instead of whole transactions. And there are other things like allowing fast exits that, again, it might not directly decrease gas costs there, but you can reduce waiting periods and skip fees. There's a lot of exciting things that are going on that can lower costs for Boba going forward.